So now we're going to do hypothesis testing for the mean. The difference here is that the sigma is unknown. So the population standard deviation is unknown. When we knew it before, we were using the normal and hence using the z standardized test statistic. So now we'll see what we do when sigma is unknown. Well, what we're going to do is we're going to use the t-test instead. Not the z-test, but the t-test, because we're going to use a t-distribution. All right, so the t-test from mean mu is a statistical test for the population mean. The test statistic is still going to be the sample mean x bar. That's still the thing that we're going to use to get our information about the population mean mu. But this time, the standardized test statistic is t, and so our conversion to t, again, has the difference just that it uses the sample standard deviation and not the population standard deviation. All right, we still need similar conditions to before. We may need the sample to be random, and we need to either know that the population is at least approximately normally distributed, or the sample size is at least 30. And the degrees of freedom, like when we used the t-distribution before, is again n-1, and that'll come into play in how we figure out p-values in using the t-test. So again, just like before, we still have three different versions of this. The difference here is just the distribution that we're looking at is the t-distribution. But still, if we're talking about looking for regions less than some t-value, that's a left-tailed test. If we're looking for some region greater than some t-value, that's a right-tailed test. And if we're looking for the regions on either side of a region, then we're talking two-tailed test. And again, this will be determined by what is in our alternative hypothesis. So let's take a look at how this would all be carried out. Again, it's going to be very similar to what we were looking at in the z-test, with the exception of using the t-distribution. All right, so we would verify that sigma is not known. If it were known, we'd be using z-test. Sample is random, and either the population is normally distributed or the sample size is at least 30. So again, like before, we're going to identify the null and alternative hypotheses, H0 and H sub A. We'll specify the level of significance alpha. We also need to make note of the degrees of freedom, one less than the sample size. Then we're going to find the standardized test statistic. Again, this time is t. Again, using s instead of sigma. So that's what we know here, s. And we want to sketch the sampling distribution to figure out what type of what tailed test we have. Now, then we're going to use technology to find p-values. Okay, so when we're doing this, we're going to be, so let me bring up here, we're going to be using these formulas here, t-dist RT for right tail, and t-dist 2t for the two-tailed. The default one again is a left tail, and the others are obviously right tail and two-tail version. And so where the Excel documentation is asking for an X, that's really our t value. the degrees of freedom, and in this case you have to say true for cumulative, the other ones don't need that. So basically you're supplying a t-value and the degrees of freedom, and you're going to get back the probability, the p, that you're looking for. Okay, so once we get that, using either our t_dist, t_dist rt, or t_dist.2t, then we'll be able to have our p-value and compare it to our alpha. And that's where we make our decision. And again, the decision is still going to be reject the null hypothesis or fail to reject the null hypothesis, depending on how p compares with alpha. And then finally, just as before, we interpret the decision. We decide whether we're in a support mode or a rejection mode, and whether we have enough information, have enough evidence, or we don't, to either reject or support the claim, based on whichever mode we're in. So everything else stays the same. It's just the use of the t distribution instead of the normal distribution here.